Guys, this is your review for function basics. So first off, we have some function notation, and it says given f of x is equal to x squared minus 4x plus 5, find the following. So we're going to substitute these values in for x. So f of negative 2 is equal to, and now I'm going to replace x with negative 2. So I'm going to have negative 2 squared minus 4 times negative 2 plus 5. Negative 2 squared, or negative 2 times negative 2, is a positive 4. Negative 4 times negative 2 is a positive 8. Then I have a plus 5 on the end. 4 and 8 is 12. Plus 5 is 17. F of 3. Same idea. Substituting in a 3 everywhere there was an x. So 3 squared is 9. Negative 4 times 3 is a negative 12. Plus 5. 9 minus 12 is negative 3. Plus 5 is going to give me a positive 2. F of a plus 3. So here I'm going to plug a plus 3 in everywhere there was an x. So I have f of a plus 3 squared is equal, or sorry, a plus 3 is equal to a plus 3 squared minus 4 times a plus 3 plus 5. So a plus 3 squared, that really means a plus 3 times a plus 3 minus, I'm going to go ahead and distribute right here, 4a. Negative 4 times 3 is a negative 12 plus 5. Now I'm going to do double distribution with these two binomials. So I'll have a times a is a squared. A times 3 is 3a. 3 times a is 3a, and 3 times 3 is 9. I'm going to also combine these other ones over here. So I'm going to have minus 4a, negative 12 plus 5 is a negative 7. And then I'm going to combine my like terms all at once. So I have f of a plus 3 equals, I have a single a squared. 3a plus 3a is 6a, minus 4a is positive 2a. And 9 minus 7 is a positive 2. That is my answer. There will be one where you have to plug this an expression in, but it won't be a quadratic. You won't have to square it, so you won't have to do this step right here. You will still have to distribute and combine your like terms on your test. Number 2, identify whether the following relations are functions or not functions. And I do have one down here that you probably don't have on your paper, so you may want to go ahead and sketch it. This is called a mapping. And you can just put a circle or an oval with 2, 4, and 6 in it. 1, 2, 3, and 4 are the range values. Notice 2 goes to 1 and 2, 4 goes to 3, and 6 goes with 4. So a function, remember to be a function that the x's don't repeat, and it has to pass the vertical line test. Those are the same thing. If it fails one of those, it's not a function. If it passes one of those, it is a function. So if I look at A, I can see that if I draw a vertical line, it will go through 2 points. So it fails the vertical line test, so it's not a function. B, any vertical line I draw will go through only 1 point, so this is a function. E, my x values do not repeat, so this is a function. D, my x values repeat, the 2's repeat, so this is not a function. E, this 2 value goes to 2 separate range values, so this is not a function. And then on my table, my x values don't repeat, so this is a function. Alright, provides information about the following relation. Okay, so it's got a graph here. Anytime it doesn't show open or closed circles, they are assumed to be closed circles. So if you want to put closed circles right there, you can. identify the domain. So our domains are possible x values, and we can see that this starts all the way over here at -5, and -5 is included, and it goes all the way to 3, and 3 is also included. Our range is from the bottom of our graph at -1 to the top of our graph at +3. Those are also included. Is the relation also a function? Yes, the x values don't repeat. It passes the vertical line test, so this is a function. Is it continuous or discrete? Continuous is when it's connected. Discrete are when it's just dots, so this one is continuous. On what intervals is it increasing? So we have two different places it's increasing. Increasing is going up from left to right. And whenever we're talking about increasing, we're talking about the x values. So it starts going up over here at -5, and it reaches its the max right here at -2. So from -5 to -2, and it starts increasing again at the x value of 0, and increases to +2. On what intervals is it decreasing? So it's increasing, it is decreasing right here and right here. So I'd say from -2 to 0, or from 2 to 3. Remember, these are again only x values. Number 4, we want to label the axes, the origin, and the quadrant. So this is my x-axis, my y-axis. My origin is right here. My quadrants start in the top right-hand corner, and they go counterclockwise. And I want to choose any 7 points and write their coordinates below. So these can be any points you choose. I'm going to pick -3, 5, -2, 3, -1, 4, 0, 6. Oh, 6 wouldn't be on my graph, so I'm going to change that to 0, 4, 0, 0. That's 5 of them. 1, 1. And 1, -2. I'm going to plot my point, so -3, -2, 3, -1, 4, 0, 4, 0, 0, 1, 1, and 1, -2. And again, these can be any points that you choose. They don't have to be the exact same points that I have. And then what is the domain of the relation? Because these points are not connected, I'm just going to use braces and list the points, the x values from lowest to greatest. So -3, -2, -1, 0, and 1. I do not have to repeat the x values that repeat. What is the range? The range starts at -2, 0, 1, 3, 4, and 5. And ask, is this relation a function? Mine is not, because it have x values that repeat right here and right here. So this is not a function. And is it continuous or discrete? They're going to be discrete because they're not connected.